Can you all see my screen?
Yes.
All right, so to get started with some background information, the PCO Atlas is a website that was created by CBIT, and they have developed the data infrastructure necessary in order to access the PCL genomic data through the web. So we can see the API documentation through this UI, and it contains a bunch of various endpoints in which you can fetch the data that you need. So this PLCO API is very important for our PCL SDK because it allows us to query the necessary data. And this Explorer website also contains plots for the analysis of the respective genomic data. So the goal of our PCL SDK is to enable, is to export these graphs in an environment that is outside their main website. So to show off the code base, some interesting things that we did are we implemented JS docs to keep track of the documentation of our SDK. And like Jonas mentioned earlier, we also used local forage in order to cache the results of the SDK. Okay, so using our SDK, I have developed this exploratory website solely using our SDK. And to give a quick rundown of
if you don't mind, when you mentioned the docs approach, just say a few words about the use of GitHub Actions to update the HTML document that describes its use, and maybe show it as well.
Oh, yeah, sure. So we also implemented GitHub Actions in order to automate the pushing and creation of the docs. So every time the main master branch is updated, it runs a series of commands that you see here. So it installs the npm package, and then it runs the JS docs using this command, and it finally pushes it back into the main branch. And you could see, if you go to the Actions tab, you could see all the previous workflow that have been ran and if they were successful or not. So this obviously makes things a lot easier and is quicker to do.
You want to show the documentation in HTML?
Oh, yeah.
Just so people see what is the final product.
So on our website, there's a link to our documentation, our code, our notebook, and a bunch of other stuff. So if you click the docs link, you can see how the website looks that was generated using this library, JS docs. So you can click on the various namespace, and each namespace represents a collection of related methods. So for our PLCO API namespace, we have a description and a couple of examples of how to use the various functions for querying data that you want. So for example, metadata, you can query the data that you want using either you could pass in a whole object, or you can use the parameter, the positional parameter, to define how you want the headers to look like.
Sorry, let's do one in the dev tools so people just see it, yeah, and lose the fear of copy pasting from your example.
So if you do not want to copy and paste it, you can actually see what each parameter represents. So the second parameter will represent the phenotype ID, and we're going to use female breast cancer as an example, which is 3080. And for sex, we're going to use female. And then for ancestry, we're going to use European. And raw indicates how the data should be formatted. So if raw is true, it would be in a JSON format, but if raw is false, it would be in an array of objects. So I'm just ignore that parameter for now, and there you go. You can see all the data that you were looking for.
Thank you, Eric. Do you mind showing one with the plot? And then I promise not to ask for anything else on DevTools, because I know you have a lot of these already embedded in your web application and observable notebook.
Are you mentioning plotting? Like,
yeah, an example of a function that plots something, and you can push it back to the web application.
And it gets populated here.
Yep, very good. So this was very fast. Are you using caching? Is that why it was so fast?
Yeah, we use local forage, and you can see all the you can see that it stores the data along with the URL that is used to obtain the data. And like you said, it just makes everything work a lot faster upon refreshing and reloading the page.
All right.
Okay, so just to like walk through the website real quick. So first up, we have the Explore Phenotypes tab, and you can use this to find the phenotype that you're looking for, and it's available in our PCOO ecosystem. So let's, for example, look up cancer by location. So let's say we're looking for if the PCO ecosystem have any data pertaining to female breast cancer. So we can press on the female breast cancer and look through for a phenotype ID that corresponds to what we were looking for. So we identified that the phenotype ID is 3080. And then we're going to scroll all the way down and just quickly confirm that the phenotype does have plotting data available, because not everything has been imported yet into a database by the CBIT. So we're just going to quickly submit it and mention here that if the JSON object is highlighted in red, it means that combination of sex, phenotype ID, and ancestry has plotting data available. So it looks like female East Asian has plotting data available. So after we confirm this, we're going to go to our Explore Plots tab, and then we're going to create our stratifications. So let's just keep on using female breast cancer, female, and let's go for East Asian. We're going to press Add. And once we're satisfied with our stratifications up here, we can press Submit, and that will generate the plots. So we're going to press Submit. And you can see the plots here. And if you want to see a QQ plot, simply press on this tab above, and you can see a QQ plot, as well as a PCA plot. So the PCA plot has options to change the PCX and PCY on the fly, as well as changing the platform. So let's quickly show an example. So once you're satisfied with how your plots look, you can also share the URL to a plot. So I'm going to show that really quickly. So it's going to copy the URL to clipboard, and you can now just copy and paste it into a different tab. And the same plot should automatically pop up and populate. All right.
It's very smooth. Very good, Eric.
Okay, so finally, we're going to just go through our others tab. And here I have demonstrated support of the EpiPlot library. So some of the pros and cons of using the EpiPlotly library is that it's really good for static plots, meaning you don't really want the data to change that often. And also it's really fast because you don't have to fetch the data from an external API. But I say the one major con is that the JSON file, which contains the plotting data, as you see here, must be hosted. So it could be hosted on GitHub, and you can see a link here. So this contains the plotting data. It's going to take a long time to load, but as you can see here. And I just have a couple of functions that allows you to download plotting data as a JSON and save it onto your computer. So I'm not going to show that right now, but we can move on to the custom elements. So custom elements, we have, it's essentially a wrapper around a function. If I can show the code really quickly. So as you can see, it's essentially just a wrapper around the functions that creates the graph. So as you can see here, but one of the major benefits is that it allows you to forgo writing the JavaScript code, as well as immediately laying out your website directly from the HTML file. So we have an example of the custom element in use, and these are the attributes of the custom elements. So you can see data input would contain the stratifications, as you saw when we were using it for the Explore, as you saw before when we were in the Explore plots tab, as well as it has custom layout, which you can change. For example, the color of the plot, and custom config for changing the config of the plotly graph. So here we have disabled zoom. So if you try to scroll zoom, it will not work. And additionally, the Mahan plot has the chromosome and p-log value attributes to specify the chromosome that you want to see. So yeah, so that's it for
Eric, do you mind as a closing example, because this use of custom elements has been object of a lot of interest and discussion in the group. Do you mind going to the HTML and just showing, so put yourself in the perspective, if you don't mind, just show these parameters a little bit so people see that you are engaging something that was assembled from a custom element, like choosing a specific chromosome, for example. You have that option at the end, right? So just pick one. And so the new plot is assembled. So this is an example where complicated code is being made available to someone else that is not necessarily someone like Eric. And so the next example, Eric, would be to open your HTML. Oh, there is, so it's done. So open your HTML and show how this HTML looks like from the perspective of someone just inserting your tools in their web page. All right, then this will be the closing example. If people have questions, this is a good time to start thinking about them before we move on to Lorena.
Yeah, so it's really just one line of HTML code. So you can see right here, that's how it's being used.
So it's a Manhattan plot element, that's it.
Yeah.
Any questions?
How did you import this tag so that it knows?
Oh yeah, so if you go to our JavaScript file and scroll all the way down, you can see here that it defines Mahan plot as part of the namespace for our custom elements.
Eric,
and all you have to do,
I think Daniel's question is, where do you load this JavaScript library in your HTML? So you have to go to the header.
Yeah, so going back to index.html, you simply just use script source plco html elements.js, and you do not need to include plco.js in your header, because it will see if it's already loaded, and if it's not, it'll automatically load the dependencies that is needed. So you don't actually have to put this at all.
Yeah.
And can you show me the HTML objects.js to show me how you loaded the plco.js in it? It's always been an issue for me.
Sorry, can you repeat your question?
Oh, you have to go back to JavaScript code that assembles the elements. You were just there before. That's it. Yeah, PLC HTML. Yeah.
Oh yeah, so in order to load the PLCO, we simply return a promise, and it creates a script tag and just appends it to the head of the document.
Yeah, it's so easy, and of course the user doesn't see any of this complexity. Then, if you have no more questions, I'm going to ask Eric because I think you forgot. You promised us to show this in as a reactive notebook in Observable.
All right, yeah. So we have a link to our notebook right here. And it might take a while because the first time you're fetching, it's not cached. But upon refreshes, it should be cached and it'll be much faster.
At the QQ plot, were you showing all of the points, or were you able to filter to just show like the lowest p-values, etc.?
Yeah, so if you were to say grab a bunch of variance points from the variance endpoint, you can then subsequently filter each data and just sort them by p-value after you fetch the necessary data. So you can quickly just sort. I don't remember on top of my head, but I think.
I guess I wanted to know if you were plotting all of the points. So it says 6 million, I think, on the graph, but the way that PLCO was doing it, they were only showing like 20,000.
Oh yeah, I think the way that Sdk made the endpoint, they sample a certain amount of points out of the 7 million variants to plot it on the QQ plot.
So that's what you're doing here?
Yeah, so it's not actually 6 million, it's more like, I want to say 20,000.
Yeah, okay, awesome, that's great. Thanks.
Larry, I think what you're suggesting is that it would be, instead of sampling, it would be more biologically interesting to just segment the lower ones, right?
I think that what's happening is the 10,000 lowest p-values are there, and then 10,000 are a sample.
Oh,
something
like nature.
A random.
Yeah, that's a nice compromise. Very good. All right, any more questions for Eric? Eric, you've done a great job. I want to finish by complimenting you. I'm clapping here. I'm not sure if you can hear. This is a great job. This will be very useful for us.
Good job.